Hello everyone, I'm Mahathi Manjapudi with Global cli-MATES, and in today's video we'll be taking a closer look at Earth's core. So to recap what we've already discussed about the core is located at the center of the Earth, underneath the mantle and the crust. Now if we consider the radius of the Earth, if we go from the crust to the center of the inner core, which is the darker orange, this distance is 6,731 kilometers. And if we just go to the edge of the inner core, we have 5,150 kilometers. So that's how deep the core extends to. And of course, while we call this entire orange region the core, you can notice that this core is divided into two structures. We have this light orange part over here and this dark orange part over here. So turning our attention to the zoomed in version, to take a closer look at the different layers of the core, we can first take one step back and look at the mantle. Right, so in gray up here we have the mantle, the lower mantle, right before it transitions into the outer core. And so just like how the transition from the crust to the mantle is a difference in chemical composition, the same thing goes for mantle to the core. And so this transition is actually known as the Gutenberg discontinuity. And the change in chemical composition is that the outer core, and the entire core actually, the entire core is presumed to be a nickel-iron alloy, as opposed to the iron and magnesium of the mantle. But it also contains a few trace elements such as oxygen, silicon, and sulfur. But basically oxygen, silicon, sulfur, those are elements that form, that readily form other compounds with iron. Now let's go into the differences between the outer core and the inner core. Because all of this, of course, is the core. And both of them are composed of nickel and iron. So, in an earlier video, we mentioned how temperature and pressure, we mentioned how temperature and pressure play a role in determining the strength of a material, especially as we go underground. And so, in the case of the outer core, the combination of temperature and pressure makes it so that the outer core is a liquid. So the outer core is actually, this flowing iron-nickel alloy that is sandwiched between the mantle and the inner core. Because it is liquid and it moves around, scientists think that the motion of the outer core actually contributes to the magnetic field. And so the liquid iron-nickel alloy in the outer core contributes to Earth's magnetic field. Another thing to note about the outer core is that it's the second largest layer in Earth, and it's approximately 2,260 kilometers thick. And then if we turn our attention to the inner core, right, now in the inner core, we have the mantle and the crust pushing down on it, but now we also have the outer core pushing on it. So since there's more pressure in the inner core, even though it's getting hotter, and even though the heat might cause, the metals to melt like it does in the outer core, because there's more pressure in the inner core is solid. So all that pressure outweighs the temperature and causes the inner core to be solid, as opposed to the liquid outer core. And this inner core is, of course, it's a smaller layer than the outer core, and its radius is 1,216 kilometers. So that's the thickness of that layer. So we mentioned how the core is this iron-nickel alloy. Iron and nickel are so much more dense than the other elements that contribute to the composition of the mantle and the crust. And because of this, the average density of the core is roughly 11 grams per cm cubed. For your reference, the density of water is 1 gram per cubic centimeter. And this is actually just the average. If we go closer and closer to the center of the Earth, the density approaches 14 grams per cubic centimeter, which is 14 times the density of water. So that's, most of the content we had for looking at Earth's core. To review, the Earth's core is the densest layer. Even though one is liquid and one is solid, they are composed of elements that have an average density of 11 grams per cubic centimeter. Again, those elements are nickel and iron. And structurally, the core is divided into a liquid outer core and a solid inner core. The liquid and solid aspects of the cores are determined by the combination of temperature and pressure. So that was all for today's video about Earth's core. If you learned something new, please like our video and subscribe to our channel. And if you have any questions or comments and suggestions for future videos, please feel free to leave a comment down below. Thank you all for listening.